Question 8. This question is about volatile liquid A. Student does an experiment to determine the relative molecular mass M of liquid A using apparatus shown in figure 2. Student injects a sample of A into a gas syringe in oven. At the temperature of the oven, liquid A vaporizes. Find needle syringe. There's a heated oven. This is a heated oven. And this is the gas syringe, right? Already labeled for us. Table 3 shows the student's results. Calculate the M of A. Give your answer through some figures. The gas constant R is 8.31 kilojoules K to power minus 1 moles per power minus 1. 4 marks. Now, it just gives us a bunch of information and it said a simple sentence. Calculate M of A. And then it gives us 2 additional points. Give your answer to 3 significant figures, which is going to be key. And also the gas constant R is 8.31 joules K to power minus 1 moles per power minus 1. So how would we even start the question? Well, obviously we're going to use ideal gas equation. PV equals nRT. Should be confident with the equation. And what if we want to find out the MR of something, we need to know the moles, right? Well, we're using an ideal gas equation, so we need N is equal to PV over RT, because we're going to need to find out the moles and then do moles is mass over MR, MR is mass of A divided by moles. So let's do that first. Let's find out the mass of A. The mass of A equals, well, these two are our mass values. Mass of the fine needle syringe and contents before injecting, mass of fine needle syringe and contents after injecting. All we're going to do is subtract these values. So it's going to be, let's show the subtraction. So the examiner knows we don't just get it out of thin air. It's shown the subtraction, how we get the mass of A. 11.295 minus 10.835. Minus 10.835. 11.295 minus 10.835. 11.295 minus 10.835, and that'll give me 0.46 grams. 0.46 grams. Now, I'll need this later on. Now I'm going to need to do a bit of calculation. So the number of moles, N, is equal to pressure in pascals. Now the pressure is in kilopascals, so what we need to do is we need to do 100. Show the conversion in pascals, so 100,000 pascals. And what do we do? Well, we're timesing by 1,000. It's going to be 100,000 times by the volume. Well, we've got two values of the volume. The volume and the reading on the gas syringe before injecting, which is 0 centimeters cubed, and the volume reading on the gas syringe after injecting, 178 centimeters cubed. Obviously, we don't care about the 0 value. We care about this 178 centimeters cubed. Now, we don't want it in centimeters cubed. We want it in meters cubed. So what we have to do, we're not dividing by 1,000. We're going to divide by 1,000,000. So what we're going to do is we're not going to times by 10 to the power minus 3. So we got 178 centimeters cubed, arrow, times by 10 to the power minus 6. And that will give me, yeah, I'm not going to work that out. But we're just showing the examiner what we're doing. So 178 times by 10 to the power minus 6. We want a meters cubed over R, which is 8.31. Times by temperature. Well, temperature is 120 degrees Celsius. We don't want it. 120. We do want it, but we want it in Kelvin. So add 273. 120 add 273. 393 Kelvin. So times by 393. Now we can find out the moles. Times by 178 times by 10 to the power minus 6 divided by 8.31 times by 393. Now I get 5.45 times by 10 to the power minus 3. Now that's the moles, and we know moles, well, we should know moles is mass over MR. Therefore, times by MR divided by mole, MR equals mass 0.46, and now we use the mass of A. That's why we calculate it first, so now we don't have to calculate at the end. Divided by the moles, 5.45 times by 10 to the power minus 3. Yeah, because MR is mass divided by moles. So 0.46 divided by 5.45 times by 10 to the power minus 3. That'll give me 84.4. And the answer must be 3 significant figures, like it said. 84.4. So a bit of a long question, but we can see most of the time it's just converting the units, and that's why you need to know your units and you need to know how to convert between them. If it means you have to keep writing them over and over again, then you're going to have to do that, because you have to know your units. Because these math questions don't really, a lot of them are just testing how well you know your units and the equations. And in 8.2, the student noticed that some of the liquid injected into gas syringe did not vaporize. I explained the fact that this has an MR calculated by the student. Well, going to be a lower volume recorded, hence the MR value would be greater than actual as a low volume recorded. And then 8.3, each reading has a certainty of this 0.001. Calculate percentage of certainty in the mass of liquid A. Well, the mass of liquid A is 0.46. So 0.001 divided by 0.460. However, how do we calculate the? It said each reading used to record the mass of the fine needle syringe and contents. So we're using two things of the uncertainty. So we need to times it by 2. Divided by mass added and percentage times by 100. So that's the tricky bit. I feel like a lot of students would get this but then forget, because it's of two things, you know, how to calculate mass, we subtract two things, we're timing it by 2. 0.001 times by 2 divided by 0.460 times by 100, and you should get 0.435%. And that is the end of question 8.